So far you've seen how to write expressions that operate on numbers, and you've learned the primitive call rule for evaluating those expressions. But numbers aren't the only primitive kind of data in Racket. In this video we're going to learn about strings, which are used to represent words and names, and images, which let us start to build up pictures. We won't have to learn any new evaluation rules though, because calls to string and image primitives work just like calls to number primitives. So even though this video is a little bit long, I think you'll find it moves along quite quickly. First we'll look at string primitives, then we'll look at some image primitives. There's one tricky part having to do with the way we number the characters in a string, but I plan to spend a couple minutes on that just to be sure to show you how it works. In the beginning student language, strings look like this. There's a double quote, and then some characters, like apple, and then another double quote. And Racket highlights the string between the quotes with green for us to help us see it. So that's a string. Here's another string, Ada, someone's name, and strings are values. So if we run the program with these two strings in it, the value of the strings is the strings themselves. So apple produces apple and Ada produces Ada. Now what are some things we can do with strings? Well, one thing we can do with strings is put them together. So let's say we have two strings, Ada, which is someone's first name, and Lovelace, which is someone's last name. We can put them together like that. And if we run that, string append is an operation kind of like plus, but for strings. It glues the two strings together like that. And probably if it's somebody's name, we might want to put another space in there. And one way to do that would be to just add a third argument to string append that adds the extra space in there. And there we go, and there we get Ada Lovelace, who you might want to look up. She's very famous for computer scientists. In the 1840s, she wrote the first computer program ever written. It was written for a machine which at the time only existed on paper. The machine itself didn't run until quite recently, but she wrote the program in the 1840s. So that's one thing we could do with strings. We've got strings, we could put strings together like that. Let me just point out one little wrinkle about strings. This is a string. That is a string that happens to have the characters 1, 2, and 3 in it. And this is a number, 123. And they're not the same. So in particular, you can take the number and add 1 to it. If we run that program, we get 124 as the result of that expression. But you can't take the string and add 1 to it. If you try to do that, you'll get this error message. Plus expects a number as its second argument. You gave it a string. And Racket nicely highlights for us where the error is. And you'll probably make this mistake. Everybody makes it at first when they're learning the difference between strings and numbers. And you just look at that and you say, oh, I meant this to be a number. And you just get rid of those string quotes. And now this program does run, and both of those are working. We get 124 twice. Okay, let me show you two more primitives on strings very quickly. What I'll do is I'll delete that stuff, and I'll comment this stuff out. So one operation we can do on strings is to take string length, for example, of apple. And string length is a primitive which tells us how long a string is, and that string is, let's see, A-P-P-L-E, 5 characters long, sure enough. So that's one thing we can do with string. There's another operation we have called substring. And substring is going to let us take out parts of a string. So if, for example, we have a string like caribou, substring lets us take out parts of the string. And let me just give you an example here. If I say caribou 2 and 4, that's going to mean take out all the characters from 2 to 4. Give us just those characters. Now that's RI. And the question is, why is that RI? Well, there's a funny little trick here that computer scientists have played on the world, which is to use something called zero-based indexing. And in order to understand zero-based indexing, the way I always do it is I make myself a string that looks like this. I make a little string that's 0, 1, 2, 3, 4, 5, 6, 7, 8. That's probably long enough for now. Okay. And what zero-based indexing means is it means that for substring, if we operate in this string here, 0, 1, 2, 3, 4, 5, 6, 7, 8, and we go from 2 to 4, it means start at character number 2 in zero-based indexing and go right up to, but not including character number 4 in zero-based indexing. So again, if you take this, what I'll do is I'll take this string here and I'll line it up perfectly with caribou. And now you can see why we get RI, because it's R starts at 2 and we end right before 4. So that's the trick of zero-based indexing. And you know, a lot of people make mistakes about this. They get what are called off by 1 errors because they confuse the zero-based indexing. Again, don't worry about it if that happens. One of the great things about computer programming is these machines are not fragile. If you make a mistake, you get an error message, not quite the right thing happens, you just fix it. I'm not saying we shouldn't worry about errors in our programs. The design method we're going to learn is going to help us prevent and find such errors. All I'm saying is, if you get an error while you're working, don't worry about it. Look at the error message and fix the problem. So just so you see one other example of substring, let's say if I say substring of caribou, and I want just the first 3 characters, I would say 0, and I'll stop at 3. And that gives me the CAR. So I've got an exercise I'd like you to do now. Please do the exercise, and we'll go on with images after this. Okay, that's some basics about strings. What I'd like to do now is go look at some basics about images. So what I'll do is I'll make a new tab. And Dr. Racket has lots of different kinds of image functions. In order to tell it that we want to use the ones for this course, we're going to type at the top of this file, and any file in this course that uses image functions, require to HTTP image. And what this is telling Dr. Racket is it means we want to use the image functions that come from the 2nd edition of the How to Design Programs book. So it's a little bit of a mouthful, but you can just type that at the top of any file in which we're using image functions. Now there's lots and lots of image primitives. Some of them make images. For example, the circle primitive. The first argument to circle is the radius in screen coordinates, or pixels. The second argument to circle says whether the circle should be solid or an outline. And the third argument is a color. So that expression there produces that red circle. So we call the primitive circle, we get a red circle. And there's lots of similar shapes. Rectangle. Rectangle takes a width and a height. And it could take outline or solid, and it has different, we can try some of our other colors. And there we go, we've got a rectangle. And there's just a whole bunch of them. I'm not going to go through all of them right now. Another one that's quite useful, though, is called text. Text takes a string, for example, hello, and a font size like 24, and another color like orange, and it produces, this is now an image of the string hello in font size 24, color orange. So this is an image now, it's not a string. So that's a bunch of useful primitives for making images. Let me talk about some things we can do with the images once we have them made. One useful primitive is above. So if I say above, we'll make a circle of size 10 that's solid and red. And I'll make another couple circles. What I'll do is I'll do this easily by cutting and pasting. And then I'll just change the sizes. Let's say we'll make this one 20, and we'll make this one 30. And to make it pretty, we can change the colors too. There we go. So now what happens when I run that is I get this stack of the images. Above takes all of the images that it receives as arguments, and it stacks them one on top of the other. So above is kind of a sort of version of string append for images. But since images can be arrayed in lots of different ways, there's lots of other functions. So in addition to above, there's, for example, beside. And if I run that, I get that shape. And in addition to beside, there's a thing called overlay. Overlay. And if I run that, overlay stacks them on top of each other. There's lots and lots of primitives that operate on images, and as you do the homework exercises this week, you get a chance to look them up and play with them. But for example, there's functions that make ellipses and stars and triangles and things like that, and you can line images up and put them next to each other in different ways. But these are a good set of basic functions right here: circle, rectangle, text, overlay, above, and beside. So I've got another little exercise you can do here to test your understanding about primitives that operate on images.